The next one, dehydration, has a mechanism that you really should know because it's going to be important for the mechanism problem that you'll have to do with this test. Well, let's take a look at dehydration. Let's look at the overall effect first. What we're doing is we're taking the OH and an H off here. So we're actually removing H and OH, which is water, which is why this is called dehydration. And if you look here, you'll see the water is actually a side product of this process. So looking at the mechanism, just summarizing it, the first thing is we have the O coming and attacking the H+, and the reason we know that the arrow goes this way is because it's the two electrons on the oxygen that are going to form this bond between the O and the H+. Remember, this arrow is always showing the movement of electrons, not the movement of these atoms. Next, we lose the water, and that leaves a positive charge on the C, and then we lose the H+ and form the double bond. And that's summarized down here. I'm actually going to go through it again, showing you the order of the arrows and their flow. So we start off with the alcohol, and we only have H+ to react it with. Now remember, we've got two sets of lone pairs on this oxygen. One set of the lone pairs is going to move to form a bond between the O and the H+. Now what's going to happen is that since we've got two electrons here, oxygen is actually going to give away one of its electrons to form a bond with the H+. That's going to leave the oxygen with a positive charge. Now remember, now in this bond you've got two electrons and one belongs now to the hydrogen. It used to belong to the oxygen. That makes the oxygen positively charged. Now the next step, you might say, we know that the O+ is going to disappear. We know the O+ wants to become neutral again. So you could say, well, we could break one of these bonds, but if we broke one of these bonds to bring the O back to not being positive, then what's going to happen is we're going to go back to here. The only way to sort of continue with the reaction is to break this bond, but the question is, how do we break it? Alright, so remembering that arrows show the movement of electrons, we start the arrow in the middle of the bond and we draw it towards the oxygen. Now remember, what we're trying to do is satisfy this positive charge, and we can do that if we take both electrons in this bond and put them on the oxygen. One electron belongs to the C and one belongs to the O. If we put both electrons on the O now, that's going to neutralize that charge and leave a positive on the C to which the oxygen was originally attached. Right, so the oxygen is neutral now. But look at the direction of the arrow. It's important to see that. It's always from the bond to the positively charged oxygen, showing the movement of electrons in this bond onto the O. Now this compound is not very happy because it's got a positive C and it wants to get rid of that positive C. And the way it can do that is to get electrons from somewhere, and what it does is it will take electrons from this CH bond. Now the arrow doesn't go towards the positive charge, it goes into the bond, and what that will do is form a double bond, which will end up satisfying that positively charged carbon atom and release H+. There we go. So now we've got a double bond in here. Now what has happened is that we have gotten two electrons here and both of them belong to the hydrogen. What this CH bond is doing is putting both electrons into this bond, which now gives this carbon the extra electron it needs to bond with this carbon so that the positive charge can disappear. Positive charge ends up being transferred onto the H plus by the end of the reaction. So the two things we get from this are H2O and H plus. Now I want you to realize the H plus is a catalyst because we form it in the beginning, so we use it in the beginning here, and it goes through the reaction and we get H plus back at the end. Obviously though, it's not the same H plus as we started with. It's one of the H's on the C's that we end up with an H plus at the end, but we still consider H plus to be catalytic in this process. This is a very important mechanism and you should practice this mechanism as much as you can so that you can understand it.